Hello everyone, welcome back to my channel. This is Jess. So today we'll be looking at a problem called top k frequent elements. So first, let's take a look at the question statement. You're given an integer array nums and an integer k, and you're asked to return the k most frequent elements. You may return the answer in any order. So if we look at example 1, if you're given this nums list or array with 1, 1, 1, 2, 2, 3, and k equal to 2, then your output should be a list of 1 and then 2, because 1 has an occurrence of 3 in this list, and then 2 has an occurrence of 2 in this list, which make them the top 2 frequent elements in this given list nums. And for example 2, if you're given a list only containing one element, which is 1, and k is also equal to 1, then your output list should be just 1. And just by reading the question statement, we can tell that the solution logic should be pretty simple. You're basically just getting the occurrence of each unique element in the list and then find the top k frequent elements. So we could pretty much just divide this question into two steps. First step would be to compute the frequency list of all the elements in the given nums array. And then once you have computed this frequency list, then you might need to sort the frequency list by the frequencies and then return the first k elements based on its frequency. So for step 1, computing the frequency list, what we could do is to build a hash map or a dictionary to store the key value pair of each element and its corresponding frequency or occurrence in the list. To do so, what we need to do is to loop through every single element in the list, and then if you see an element that is not in the frequency list or the hash map, then you add it into the map and then set its frequency to 1. If you have seen an element that's already in the hash map, then you just simply add 1 to its frequency. And once you have this hash map, you could just sort each key value pair by its value, which is the frequency of each element in the list. And once it's sorted, you just get the first k key value pairs and then store the key, which is the element itself, into a separate list and then return that list. Pretty simple, right? But the tricky part about this problem is actually the runtime and the space complexity analysis, and whether or not we could optimize its runtime. So let's talk about the runtime for the implementation that we just talked about. For step 1, creating the hash map, since we're looping through every single element in the list, that's going to be a big O of n runtime. And then creating this hash map, meaning that adding new key value pairs to the hash map or modifying the existing key value pairs value, which is the frequency, that's just going to be constant time runtime, big O of 1. So in total, for step 1, building the hash map, it's going to be big O of n runtime. And then we said we're going to sort this hash map by its frequencies, by its value. And for sorting, if we're using the default sort method in Python, then it's going to be a big O of n log n runtime. So far, our overall runtime is going to be big O of n log n. And then once it's sorted, the last step is to get the first k elements or the first k key value pairs from the hash map, and then store the key, which is the element value, into a separate list. And that is going to be a big O of n runtime. So in total, the runtime for the implementation that we talked about is going to be big O of n log n, which is alright, but we could definitely do better than that. So an optimized solution to this question, well, we still have to find or build the frequency hash map for all the elements. So step 1 stays the same, and our runtime for step 1 is still going to be big O of n. But for step 2, the previous solution that we talked about, we were sorting every single element in the hash map. But do we actually need those? The answer is not really, because for the final result, we're only looking at the k most frequent elements. So here, heap comes into play. We could definitely replace step 2 with a heap, and the heap only going to be having a size of k. So how do we keep the heap size at k? You might wonder, since we definitely have to pass in all the elements with its frequency into the heap to get the k, the overall k most frequent elements. Well, to keep the heap at size k, what we're going to do is to first, we're going to add those frequency elements pair into the heap. And then once we have added k of those pairs, the next pair that we're going to add, we're also going to be popping the least frequent element frequency pair from the heap. So this way, we could always keep the heap at size k. And once we're done with adding all the frequency element pair into the heap should contain the k most frequent elements with its frequencies. So now let's actually talk about the runtime for building the heap. The first k element that we're adding into the heap, for each element, the runtime is just going to be big O of log k. Then for the k plus 1 element that we're adding into the heap, we're also popping the least frequent element from the heap, and the popping is just going to be big O of log k as well. And we're going to do this add new element and then pop the least frequent element step for n minus k times. So in total, for building the heap, our runtime is going to be big O of log k times, that's for the first k elements, plus big O of log k times n minus k times. So in total, it's going to be big O of n log k. And then once we have this size k heap computed, we could just add those elements into a list and then return that list. And the runtime for that is going to be big O of k. So in total, this solution is going to be big O of n log k runtime. Slightly better than our big O of n log n runtime. So now let's start coding this out. First thing first, we're going to check for null for the inputs. If not nums, then we just simply return an empty list. And then we also saw in the second example, if there are k elements in the given input, then we could just simply return the nums list. So if the length of nums is equal to k, then we just simply return nums. And then we're going to do something very magical, at least I think it's pretty magical. There's this function in Python 3 called counter, and it helps you to create a frequency hash map. So we're just going to call our frequency hash map as count, and it's going to be counter and then pass in nums. So count is our frequency hash map. And then for the next step, there is also a pretty awesome function that comes with Python 3's collection Heap. It's called nlargest. So for nlargest, it basically helps you return n largest element from an iterable. So in our case, it's going to be a hash map, and it takes in 3 parameters. The first one is a number specifying how many elements you want to return. And in our case, we're returning k elements. And then for the second parameter, it is a iterable, meaning that the elements you want to iterate through. So in our case, it's going to be the keys. And then the last one, it is an optional parameter, and it's called key. But this key is basically what you're comparing those elements with. So in our case, we're comparing their frequencies, which is the value in this key value pair from the hash map. So our key is just going to be count.get. It is a function, and let's run it. Submit. So like I said, the runtime for this solution is big O of nlogk, and for the space complexity, we're storing every single element with its frequency in our hash map. That's going to be a space complexity of big O of n, and we're also storing or building this size of k heap, and in total, space complexity for this function is going to be big O of n plus k. Alright, so that's it for today's question. I hope you enjoyed this video and the solution. Feel free to post any comments, questions in the comment section, and I'll see you in my next video. Bye!